So here's our problem set number 1. A uniform rod of length L and a mass M is attached to one end to a frictionless pivot and is free to rotate about the pivot in a vertical plane. The rod is released from rest in the horizontal position. What are the initial angular acceleration of the rod and the initial translational acceleration of its right end? So given with this problem, we have to express an algebraic acceleration for angular acceleration as well as the translational acceleration. Given with the formulas, we have torque is equals to force multiplied to the radius, as well as torque is equals to moment of inertia multiplied to the angular acceleration. And we could say that the force of the object is equals to its weight, and that is mass multiplied to the gravity multiplied to the radius. Now, the radius here, since it is a uniform rod, we could expect that the center of gravity is at the center of the rod, and therefore we could expect that is at L over 2. Then therefore, we could expect that the radius for our equation is L over 2. Now, how about for torque? We have the moment of inertia of this rod. Now, let's look at the moment of inertia for this rod. This is the rod about the end. So we have this formula 1/3 multiplied to ml square. So we will write here 1/3 multiplied to the mass multiplied to the L square, then multiplied to the angular acceleration. And we could now work our equation. So we have torque is equals to mg all over 2 and equals torque to 1/3 multiplied to ml square multiplied to angular acceleration. So we have here mg L over 2 equals 1/3 ml square multiplied to angular acceleration. We could take note that we could now cancel the mass, and then we could also cancel the L square, and then we have here the L. We could have now this L, and then after that our equation would be G over 2, and that is L multiplied to angular acceleration multiplied to 3. Solving now for angular acceleration, we have 3g over 2l. Now, how about for translational acceleration of its right end? We have the formula for translational acceleration, or better known as the tangential acceleration, angular multiplied to the radius, and then therefore translational acceleration equals the angular acceleration, that is 3g over 2l multiplied to the radius. Now we have to take note that the radius is, we're getting the right end. So from this point up to this point, and then therefore we are considering multiply it to L. And then therefore we have now our final answer, which is 3g over